Hi, today we'll go into the properties of sulfuric acid. The properties generally we classify them as physical and chemical. So among the physical properties, let us just see the things that stand out. The first thing is, it is dense means denser than water. Okay, it's oily liquid. And the most important thing is, it is hygroscopic. What do you mean by the word hygroscopic? It has a strong affinity for water. Anything that has a strong affinity for water is termed as hygroscopic. That's why wherever you have sulfuric acid, it can just absorb moisture. Wherever moisture is present, water is present, it can just absorb it. And that is the reason why sulfuric acid is used as both a drying agent and a dehydrating agent. Drying is superficial. Dehydrating agent means it will absorb moisture from the structure of the compounds. So that's because of its hygroscopic nature. The next important thing about sulfuric acid is that its boiling point is very high. It is 338 degrees Celsius, and that's what makes it non-volatile. It will not evaporate easily. Okay, so and dilute sulfuric acid is a good conductor of electricity. So these are the striking points on the physical properties of sulfuric acid. Now we move on to the chemical properties, where sulfuric acid exhibits different kinds of properties based on whether it's dilute or concentrate. So if you take the dilute acid and concentrated acid, okay, in the dilute it exhibits acidic properties. Then it also proves itself to be a dibasic acid. When you come to the concentrated, it is a strong oxidizing agent. So it has oxidation reactions. Then it is non-volatile. So it can displace a volatile acid from its salt. Then it is a dehydrating agent. Which means it can remove water or moisture from the compounds, from the structure of the compounds. Water can be removed. So these are the three different properties that we see under the concentrated acid. And under the dilute acid, it exhibits acidic properties, and we also prove that sulfuric acid is a dibasic acid. Dilute sulfuric acid exhibits acidic properties. It behaves as an acid. Why does it behave as an acid? Because it forms hydronium ions in water. reactions that it exhibits. The first of the reactions is with metals. It will liberate hydrogen. So if we take a metal like zinc, it reacts with dilute sulfuric acid to give zinc sulfate plus hydrogen. So hydrogen is liberated. Similarly, if iron reacts with dilute sulfuric acid, this again gives iron sulfate plus hydrogen. This iron, even if we have iron nails, okay, it's grayish in color, this changes into a green colored solution. So there is a change of color here, and here also hydrogen is liberated with metals. The next thing that we see is with bases. And when you talk about bases can be of two types. One is metallic oxides and the other one is metallic hydroxides. Both of them would undergo neutralization reaction. What do you mean by neutralization? When this acid reacts with a base to give salt and water. Okay, now let's see the metallic oxides, the reaction of metallic oxides. There can be quite a few of them, like sodium oxide, magnesium oxide, zinc oxide, and maybe copper oxide. Okay, this reacts again with dilute sulfuric acid to give sodium sulfate plus water. Magnesium oxide also reacts with sulfuric acid to give magnesium sulfate plus water. These are simple neutralization reactions. They are all balanced acids. Copper oxide plus sulfuric acid gives you copper sulfate plus water. This alone, this is black colored powder that becomes a blue colored solution. Okay, so this is to be made note of. All others would give you salt and water. Let's move on to metallic hydroxides. We can see now sodium oxide, so we can take sodium hydroxide, and maybe among the three we could take zinc hydroxide. So these two would react with sulfuric acid, and by the way, all these would be dilute. Again, to give you salt and water, this would give Na2SO4 plus water. So this would be 2 here, and hydrogen is 4, so 2H2O. This gives you zinc sulfate plus water. 2 here. Yes, this is metallic hydroxide. Next we move on to carbonates with metallic carbonates and bicarbonates. This would give you salt, water. Because the carbonate has CO3, in addition to that it would also give you carbon dioxide. So let us see two things, sodium carbonate and copper carbonate. This reacting with dilute sulfuric acid again to give you sodium sulfate plus water plus carbon dioxide. Copper carbonate plus dilute sulfuric acid would give you copper sulfate plus water plus carbon dioxide. So in these two cases with carbonates, it gives you carbon dioxide. Okay, now let us take bicarbonate. Any one would do, say potassium bicarbonate or even sodium bicarbonate would give you the same thing, will give you potassium sulfate plus water plus carbon dioxide. Okay, 2 here. So yes, again this also gives you carbon dioxide. With sulfides and bisulfides, dilute sulfuric acid would give salt, water and sulfur dioxide. Let us take sodium sulfite plus dilute sulfuric acid to give sodium sulfate plus water plus sulfur dioxide. Similarly, if we take sodium bisulfite plus dilute sulfuric acid, also would give sodium sulfate plus water plus sulfur dioxide. Now here the gas that is formed is sulfur dioxide, whereas here it is carbon dioxide. And remember, all these are with dilute sulfuric acid. We should never miss this dilute sulfuric acid. And the difference between the two is both are giving salt and water. Both are giving two gases which will turn lime water milky. But if when you add to this, if you add potassium permanganate, this will become colorless with sulfur dioxide. But with this there is no reaction. Okay. Similarly, this is the first test. Second one is with potassium dichromate, that is orange in color, with sulfur dioxide would turn green. But again, no reaction with carbon dioxide. Okay. Now we move on to the last set, that is with sulfides. With sulfides, you have a rotten egg smelling gas, that is hydrogen sulfide, that is evolved. Okay, so that is the gas here. Again, let us take sodium sulfide, maybe we can take zinc sulfide and iron sulfide. When this reacts with dilute sulfuric acid, again you would get sodium sulfate plus hydrogen sulfide. Zinc sulfide reacts with dilute sulfuric acid to give zinc sulfate plus hydrogen sulfide. Iron sulfide again reacts with dilute sulfuric acid to give iron sulfate plus hydrogen sulfide. So these are the reactions that give you hydrogen sulfide. Now this hydrogen sulfide, when it is added on, or lead acetate solution is added to this mixture, it forms a black precipitate of lead sulfide. Okay, so that is how we identify this gas, sulfur dioxide. Carbon dioxide turns lime water milky, but no reaction with potassium permanganate and potassium dichromate. These are the acidic properties of dilute sulfuric acid.